The broadcast is now starting. All attendees are in listen-only mode.
Hello, and welcome to this IMARC webinar called The Future of Plant and Processing. My name is Diana Drinkwater. I'm a director of the AusIMM and a principal consultant at Mineralis. So I'm going to be moderating today's discussion. And I'm about to introduce you to our panelists and kickstart the conversation. There's a few housekeeping items to cover off. First of all, I'm sure you're all aware the webinar is being recorded. We will be emailing a copy of the recording to all registrants. So if you need to drop off at any time, don't worry. You'll be getting the rest of the conversation in your inbox tomorrow. This session is designed to be interactive. We're running polls through the conversation that we really encourage you to take part in. It will add value, and we welcome any questions or comments that you have. Simply type your question into the questions tab, which you should be able to see on the GoToWebinar panel on your screen. If you do experience any issues with sound, we recommend that you exit the webinar and log back in. That seems to be the best way to deal with that. So today I'm joined by three panelists: Simon Adams, Lifecycle Development Manager at Sandvik. Hello, Simon.
Hi, Diana. Thanks for having me here today.
And Ben Adair, CEO and Managing Director at CRC Ore. Hi, Ben.
Good to be with you, Diana.
And Bjorn Dierks, Global HPGR Product Specialist at Weir Minerals.
Hi, Diana. Also, a big welcome to all the people dialing in.
Great. So we have access to a broad range of expertise and a huge depth of experience in this group and some different perspectives from industry. So welcome to you all. So with that, let's jump into the discussion. The reason we're having this discussion is because we're curious to know what we're facing in the future. So I'm going to start with Simon from Sandvik. What are the big challenges, Simon, that plant and processing operators are currently facing?
I guess there's a couple of different scales, but for the majority of what I've seen, probably over the last 5 to 10 years, is you've got a lot of remote operations, or super centers, which are gathering all of that information and putting it into a single point of center. And the issue with that is that the operators are not close to the machinery that they're actually operating. So there's a bit of a lack of, I guess, operational experience on hands-on of the actual equipment. Rather, they are seeing things from a bit of a distance, which does have its challenges. They don't really understand how the machine's operating physically, that's mechanically and electrically. And they do have, more and more times stricter guidelines on how to operate the machine. So it might be, to power, pressure, closed side setting. They're very fixed parameters, and potentially they don't understand what will happen when the machines go out of those parameters and how to bring them back. So that's, I guess, that's one of the challenges, or a couple of challenges that I've seen to date.
That's very interesting. I'll go to Bjorn second. What are your thoughts about that? And other big challenges.
Yeah, I agree with Simon on that as well. But maybe just putting it from a general perspective, I think we can all agree that our customers are under immense pressure to reduce energy, consume less water, and reduce carbon emissions in general. And I believe this pressure is higher than ever at the moment. And as the OEMs of the equipment, we have the responsibility to push the boundaries with clever technology and to support our customers during that challenging operation at the moment. As overall commodities are depleting, companies are making large investments in new plants to dig deeper, crush more competent ore, and also, as Simon mentioned, at remote locations. So not only from an operational perspective, but also from an infrastructure perspective, where there is lack of water or lower access to power, to achieve those same recovery rates as we had in the last 20 years. So we, as an organization, as we are, we try from our engineers backgrounds, and we try to come up with innovations to support our customers as such.
Yeah, so Simon's talking, if you like, about the challenges of the new work environment, and you're thinking a little bigger picture about the pressure that customers are under. I'm going to go to Ben now and ask him for his thoughts about the future challenges.
I completely concur with my two colleagues, and it's interesting that the word water was mentioned several times by both of them. I think that is one of the major challenges for the industry going forward. The industry is simply not going to have access to potable water, and it's going to have to head rapidly towards a closed loop situation. Otherwise, the costs will be simply extraordinarily prohibitive. Most of our work is done in the sorting space, so it's patently still ridiculous, and it has been for the last 15 to 20 years, that we mine something and stick it through process plants, very expensive process plants, lots of energy and lots of cost, when in fact 99% of it plus has absolutely no value whatsoever. So I think if you're looking at the mine, the future is going to be in exploiting heterogeneity at the face, as opposed to deliberately destroying heterogeneity and looking for a homogeneous feed to those downstream process plants. We're doing a mountain of work with a variety of mining companies looking at completely new sensor-based sorting opportunities. So I think the future is going to involve different mine extraction platforms. They're going to be bristling with sensors, and they're going to affect decent amount of gang rejection, 35–40% of the material being rejected. And then I think that there's also a major requirement for a rethink of what the process plant and the process objectives are of the future, because that feedstock is going to be quite different going forward. And there's a crying need, and we think there are pathways now to completely look at fresh approaches to comminution and longer term to remove SAG mills and ball mills from that process. There's certainly a crying need for better classification within the system. And I think that if you look at a process plant in the next 5 to 10 years, you'll see that flotation in its conventional form might be employed to clean up concentrates, but it certainly won't be the dominant separation technology within the process plant. So overall, I think the generation of self-draining waste streams, which means you don't need tailings dams, far more energy efficient plants, closed loop water, and effectively becoming linking all that together, and this is the critical bit for digital. There needs to be a digital fabric that's overarching across those different silos to affect both temporal and spatial information, to make sure that you can continuously flex and change and inflect to optimize processing. So I think that inflection point within mining is really not that far away at all, and I think it's going to produce a future that's going to be a lot more profitable, using a lot less water and a lot more energy efficient.
That's great. Yeah, very interesting response, Ben. And it does lead into the next question about digital plant. You've talked about some of the challenges that we've got to face, and a lot of the things we have to be much smarter about. And digital technology does give us the opportunity to actually build those kinds of plants and run those kinds of plants. So I'm going to go back to Simon for his comments on reflections on what you said, Ben, and comments on how digitisation is going to affect, say, his world going forward. Simon.
Yeah, so one of the things, I guess, the guys have mentioned around about power consumption. So, one of the things that we find is through the comminution circuit is the more steady state you can get, the better you can actually utilize your power. And understanding what that is, being able to, collect that type of data. So, the machines have been automated for a long time now, but we haven't been collecting the data or capturing that data as efficiently as what we could. And that's something that, everybody's moving towards right now. Getting those steady state operations, if you can have digitalization and automation, that moves towards a cognitive behavior. Once you get those algorithms down, you can have far more efficient plants operating through, through that process. And that's kind of, I guess, the fun part about digitalisation and the way that we're moving forward is, how efficient can we be? If we want to talk about being on the ground, having that cognitive behaviour to be able to predict failures far before the time comes that they actually do fail, and also looking back through fault finding. So the more machines you can get connected, the better chance you have of understanding that data and moving forward. And I think efficiency through steady state is exactly what everybody needs. And we talk a lot about cost of a widget, but what's the cost of operation? And I guess that's the bigger picture of what we're looking to in the future, and the future is now, I guess.
So managing the machine parameters is one part of achieving steady state, but what about managing the heterogeneity, or at least the variability that you're going to be stuck with the ore that you can't manage out, you've just got to deal with? What sort of opportunities do you see digital technology providing there?
Yeah, look, I mean, as far as the comminution circuit goes, our machines are very good at understanding what the requirements are to maximise the performance. So as the ore changes, the machines are automatically changing as well to manage that ore. So that's obviously through a comminution circuit, not through the milling circuit. And that's something that we're doing right now, and I think a lot of others are doing it as well.
Yeah, so let me ask Bjorn, what have you got to add to that?
Yeah, I agree, absolutely. I think digitalization as such is a rather big word and can be interpreted in very many ways. At the moment that we see it mainly in the advantage of allowing our machines to communicate digitally, which keeps the assets more interactive and focus on cost reduction and to avoid unscheduled maintenance, which of course is a key focus for the miners to keep the availability of the assets up and running. But also from a process and comminution perspective, if changes are being made, that you can also measure what the efficiency actually is and compare that with historical data to assure that those mechanical changes and implementations actually contribute to the overall mining strategy of the plant.
So it's a big picture, isn't it, that a whole lot of different players are going to be contributing to. Ben, have you got anything to add about how that big picture is going to be managed in the mine of the future?
So I agree with both my colleagues again. It's extremely important to optimize and run your existing equipment to the best of the ability. I would argue that on most sites that I visit, that's simply not the case, and I think we're a little bit delusional if we think that we're there at the moment in a digital sense in optimizing various grinding circuits. That's certainly not the case, and I think we also need to remember that we're talking here about a comminution system that's less than 5% efficient. So when you walk into a grinding circuit, and I've been a concentrator manager in industry, you'll always walk into a circuit that's warm and hot, because greater than 95% of the energy that's in those machines is actually generating heat, which is the reason why it's hot. They're certainly not breaking rock sufficiently. So I think we need to absolutely have a digital fabric that ensures that existing equipment runs as optimally and as smoothly as possible. There's very straightforward KPIs to look at, and they could be applied quite widely and quite easily within companies and beyond. Other companies looking at how you run your operations and your maintenance effectively to make sure you get the right life of liners, and et cetera, et cetera. But I think there's also a need to recognize that we actually need different styles of comminution equipment and different approaches to comminution strategies even with that existing equipment. And I think that talks again to the heart of, one of the poorest cousins within a comminution circuit is the classification systems. The classification systems are dreadful, and it's part of the reason why we grind the living daylights out of material in the secondary grinding process. So if you grind well beyond that what you need to actually extract copper or the lead, zinc, or whatever from the material, what you're generating is very, very fine waste streams from which you will not recover the water. And so you'll have back again to this issue of having to have tailings impoundments. And I would suggest that that's actually going to be something that's in the future not going to be acceptable for the industry. So somehow you've got to generate self-draining tills. And that goes to the heart of what separation technologies you should be using to ensure that you don't have to grind the living daylights out of something way beyond the liberation requirements that you need. So I think there needs to be ongoing incremental work, but also some thought given to the types of developments that are needed to change the dial significantly within the comminution circuit of the future.
And that's all about operating practice and the nature of the workplace and so on. I'm just going to mention that we are running polls through this panel discussion. So we're about to put an online poll up now. So those of you in the audience are going to get the opportunity to answer the question, how you feel about the move to the digital plant. There it is in front of you. At least I'm seeing it on my screen. Hopefully you can. While you're asking, I'm interested and I'm really intrigued by how this conversation has gone towards work practices. By all three of the panelists have talked about the issues that we have from that point of view rather than talking about widgets and technology. But I am interested in what technology areas you think there's the greatest opportunity. I better pick someone. I'll pick Simon again to answer what technologies and innovations you think are the best available to improve the way we optimise our processing plants. I guess with a focus on comminution.
Yep. You know, firstly, having a machine that's fully automated is key to start off with. So through your crushing circuit, screening circuit, anything that you can have that's automated and set up. So you set it up one time and basically hit the button and away you go. I think that's super important, but it's also just as equally as important to be collecting that information. So once, I think John said, once you've got all your equipment connected and talking to each other, you can have remote real-time support across those operations. The other thing is, understanding fleet health, the way that the machines are actually operating and the condition of those components within that equipment, and then taking that information, and I guess you can talk about analytics and process optimization. So collecting the data, having an automated machine, connecting that equipment, and then analyzing the data for process optimization. I guess that's kind of where I feel one of the most important parts is you can't really, you can have one, but without all three of them together, that's where it's going to be optimum for the future.
Okay, so our poll results are coming up on the screen, and it sounds like the audience is pretty much in favour of the move towards digitisation, which is a good thing, I guess, because I don't think there's anything we can do to stop it. I think it's with us whether we like it or not. So there are a lot of positives, and I'm pleased to hear to see that positive view. I'll go to Bjorn and ask for the Weir Minerals view, if you like, on the most promising technologies and innovations for plant optimization. What do you think, Bjorn?
Thanks, Diana. And again, I agree with both of my colleagues, but I find it very interesting what Simon and Ben both are highlighting, but particularly Ben as well, that there is a lot of optimization required and possible within the comminution circuit and the gasification. It always strikes me, whilst putting it into real tangible numbers, that about 3% of the global energy consumption is being consumed by crushing rock. So if we can all contribute to being a bit more efficient with the comminution, that can massively contribute to the overall operation and the industry moving forward. At Weir, we believe that the way moving forward is to apply high pressure grind rollers, so in short HPGRs, with the more competent ore bodies coming forward. And with respect to the actual optimization, that can contribute to making traditional circuits more efficient, but also become the standard for hard rock refill applications. So to put a number against it, we have seen, and we've done many studies and implementations itself, that we can reduce the energy by 40% in comparison to traditional milling circuits. With respect to classification, we have been developing a dry air classification system, where I'm also very excited about to present a bit more at the IMARC itself. And that enables fine grinding, so full fine grinding up until the micron size fraction without a single drop of water, which contributes massively to those remote locations and decreased cost of potable water.
Okay, and what about classification efficiency with that technology?
That technology has already been proven in the cement industry for many years, and we have developed that into the mining industry to make it more wear resistant. And with respect to classification efficiency, our target point is always to meet 90%, and we have also demonstrated with site practices.
Okay, so some interesting new technology, as well as, I suppose, more sophisticated instrumentation and monitoring systems. Ben, what are your thoughts about the technologies and innovations that have the most promise?
So I completely concur with the idea that classification should be a serious element of it. If you think about it, that actually links the various stages and essentially is such a critical component in the whole optimization of a separation circuit. I'm aware of a number of new developments that are working, and Bjorn has just indicated another one, which is very exciting. I think that as I said before, it's been the poor cousin for a long time within the process plant, and I think it'll make a profound impact. New classifications in the wet area, by the way, would also assist with water recovery within thickeners and stuff like that, so it can be applied right across elements of the circuit. In regards to separation technologies, we already have technologies that are effectively off the shelf. So if you're looking at a far better separation efficiency in for fine particle recovery and things like that, then you know there's the Woodgrove technologies, there's the Airy stack cell. What's really intriguing for me is the fluidized bed technologies, things like hydrofloat and stuff like that, which will effectively allow you to recover at a much coarser size, and that has some profound implications for gang rejection within your own comminution circuit. So if you think about it, you know, we're focused on gang rejection up front in the mine. If some of these technologies can be applied properly and their development further enhanced, there's every opportunity to reject gang within the process circuit as well, and that really does change the game as far as waste streams and disposal is concerned. So I think all of that is there. I think we have an exciting future, and I think it's realizing within the next 3 to 5 years, we're going to see very different things being retrofitted onto the process circuit. Nobody's going to throw away their SAG mills and their ball mills overnight, but I certainly think that there'll be retrofit opportunities for these other technologies to come into that. To get back to the digital, I think the glue or the blood stream that connects all of that together right across the value chain from mine and mill and beyond is the digital opportunity. And I think if that's not realized, then I don't think we can take full advantage of different point solutions, no matter how wonderful, if they're not properly integrated. So the digital fabric affords us the opportunity to integrate both existing developments and new developments properly, and to optimize it in real time, given all the developments in computing power, etc., that's occurred over the last 4 to 5 years. It really provides us with the opportunity to take advantage of that and to optimize it. So you cannot understate the need to have that connecting fabric to allow that integration to properly take place right across mine to mill, whether it's open cast or underground. You need that digital fabric.
Great. Yeah, very interesting. And in fact, we have another online poll about some of those aspects of the technology to support digitisation. So that should come up on your screen again at any moment. So what aspect of the things, in fact, Ben, you actually talked about all of these things when you talked about managing the data. So we've got 3 initial points there: robotics, artificial intelligence, and big data. So which of those do the audience feel has the most potential to deliver the kind of control systems that all our panelists have been talking about? Or is there something else? We have given you the opportunity to put other in there. Okay, so I'll go back to Simon and Bjorn to talk a little about the way that data is managed with the technology that they've been talking about. Simon?
Yep.
Do you have
thanks, Diane.
Yep, go on.
I guess you know what's something that's super important is that we turn that data into knowledge, and how we do that is through reporting, through insight benchmarking. By doing that, we're able to increase our operating efficiency. You know, you've got cost control. We also have kind of missed the about improving health and safety. So the more automated, we don't have to have the people out in the plant taking readings off analog gauges and things like that. That everything, all the information is coming back. So you do have less people out in the field. But going into the actual data and what you can do with it, if we set up I guess a dashboard and go through what sort of power consumption you're using, are you energy efficiency, predicting maintenance, getting to that cognitive stage where we can foresee failures or predicted failures coming up, that we can capture them early, shut down in a organised fashion. There's nothing worse than having a piece of a plant or equipment go down, and then I guess you're rushing to get operational again where it was not predicted. So all of these things come in under performance and tons on the ground, and also health and safety. So there's a lot that we're doing in that space at the moment to support our customers.
So in fact, you've mentioned all 3 of the things that are on the poll. The artificial intelligence stuff is intriguing, because it sounds like you are talking about using that to learn how things are going. And as I'm speaking, the poll results have come up in front of us, and it looks like the artificial intelligence option is the one that people see the most promise in. I'm not able to see what's showing under other, so I don't know whether the organisers are able to be intrigued to see what came in there as other technologies that our audience thinks are really significant game changers. I will go to Bjorn though, and just ask if he has any comments about what we just saw in that poll result, and also the aspects that he believes are going to have the biggest impact in the world that he's operating in.
Yeah, I think machine learning can be one of the most exciting things moving forward. But I think Ben already covered the majority of all the components. I think safety is also the biggest return, apart from managing the assets itself. But it's all about the capturing of the relevant data and select the parameters and also the sequence of those parameters to become valuable. It's one thing to collect a bunch of data, but to be clever with it and to actually cast that into relevant information, that's a challenge moving forward. And I think being in the real world, we can make some steps on that progress moving forward as well.
Yeah, really interesting. And lots of you are talking about things we're going to have to do, and I think by the word we, you're talking about human beings. So I don't think anybody really believes human beings aren't going to be in the picture going forward, but I'm sure human beings aren't going to be playing the same sort of roles that they're currently doing. So I'll move on with a question to Ben, which is, and I'll put it to all three of you eventually, is what your view is, Ben, on what the role of human beings is going to be in that plant of the future.
So look, there was an old adage, I think it was 1995 or 1996, that Brian Flintoff, ex-Metso guy and ex-University of Alberta, wrote a process control book, and he called it One Man and the Dog, and the plant of the future is operated by a single individual, and the dog's there to bite his hand if he tries to actually touch anything and the plant to change anything in it. So that was written something like 20 years ago. I think there's obviously always going to be a requirement for human beings to be involved. I think the biggest single requirement for the human psyche or the human culture to give real effect to what everything that we've talked about previously exists, and that is a radical difference to the manner in which we do business within the mining industry. So, you know, a few years ago, BHP did a landscape survey, and it basically said that it took, on average, around 13 years from ideation to implementing a new technology in the mining industry, an average of about 13 to 14 years. And if you look at I'll just use Metso again. If you look at Metso's Vertimill technology, it took around 20 years for them from ideation to get market penetration. It took about 20 years in the Vertimill's case, you know, about 20 years ago. They developed their rolls crushing alternative to what Bjorn was talking about. They developed their HRC in 5 years, and they did that because they had a partnership, in this case with Freeport, the mining company, and they effectively developed a co-creation partnership. And I think that that is the future between OEMs and end users. I think that there is a crying need for those types of co-creation partnerships where you're bringing in different technologies. I stress again, there's no magic bullet here. There's no single technology that's going to create the change. However, integrating different technologies in a much better way and developing modifications to them in that co-creation framework, that I think will allow rapid prototyping and rapid implementation, and in an integrated fashion. So I think if that business culture changes from either a master-slave relationship when times are pretty bad, or a gouging relationship when times are pretty good, between the OEMs and the mining companies, and for that matter, researchers as well. I think if you have a co-creation partnership to give real effect to things on a plant where you're bringing different groups together, not just one group, but several groups together, I think you'll see that development cycle be far more analogous to the example that I gave you, and you can see some of these things being implemented in a 3-5 year time frame as opposed to the traditional 14 to 20.
Yeah. That's really interesting. And those different groups, as you say, represent different, if you like, bodies of knowledge or communities of knowledge, and bringing them together means that we're going to be accessing all the available knowledge we have in that space. That's a great point, and I'm going to pick up on that with Simon in a moment. But before I do, we have one last online poll that I'd like to put up there for our audience. What do you think is the biggest inhibitor to the digitisation of plant and processing? Is it cost? Is it people? Is it technology? Or is it, if you like, culture, industry resistance to change? So while the audience is having a think about that, I'll go to Simon and ask for your comments about what people are going to be doing, and also what we need to address from the point of view of retaining or making the best use of knowledge.
Yeah, look, Ben made a fantastic point around about collaborating with, you know, OEMs and miners. The reason that you're able to do, you know, have such speed to market is because you're tailoring or customizing that exact product to an exact point of requirement for the miner. And you also, I guess, have a shared outcome, a shared result, and you also share the risk. So as you go through and partner up with someone, the trust level becomes very, very high. That you're able to, share a lot more with each other about, each other's, I guess, operation, whether it be, engineering or the actual operations and the data that comes out of it. So you're definitely going to get a lot better, collaboration, and again, that creates that speed to market. One of the going back to the question around people, there's a reason that all of our, junior, primary schools through to high schools and beyond now are all running a STEM program. So, science, technology, engineering, and mathematics outside of the traditional, classroom programs that they run is all around, automation and large data and, technology and the future. So, as the generations and as the years move on, if it's 10 years that move on, you've got a whole new generation of people who require, have a new skill set and are moving towards that, that digitalization space, and they're already trained on it. So they're gonna need it, even down to, such small things that they're already gonna know that, they're gonna know things that I don't even know now. And probably for everyone on the panel and listening in the next 5 years' time, the technology is going to change again. That the younger generation that coming through, that's their norm, and it's not going to be for us. So, resistance to change, I suppose there's still a little bit of that, but as the poll said, people want to move into digitalization. So that's fantastic to to hear that people want to be in that space, because that's definitely where we are moving. One of the restrictions, I guess, or limiters, inhibitors are, how secure is that data coming out? So, people wanting to protect their data, or not letting, the industry leaks and things like that, which are starting to come up now, where yes, we can have large data, yes, we do have analytics, yes, we do have all of these things, but the agreements, and again, talking about speed to market, once you got that partnership, then that information can transfer easily. Without that, that's another inhibitor with the digitalization space.
That's a great point. Thank you for that, Simon. So I guess a slight twist on the question, Bjorn, I'm going to ask you this next one. There's a lot of talk about attracting new talent to the industry and different kinds of talent to the industry. So I wonder if you'd like to reflect, Bjorn, on the role that the digital plant has in attracting new talent to the industry, and also the challenges of bringing new talent to the industry. Oh, and before I let you answer, the results of my poll are up there. And what I find fascinating is that nobody thinks people are the problem. So that's really nice to see. Industry resistance to change is there, and that's culture rather than people themselves. So really interesting. You can all think about that as well. But Bjorn, I'll come to you with this question because we're going to have to wrap this up fairly soon. But I'm really interested to hear your views about bringing new people in.
Yeah, thanks, Diana. I think that's a massive opportunity for the industry, which was relatively traditionally as well. But all these new clever technologies also enable traditional software programmers or even people from the gaming industry to come and work in the actual mining industry. I find it quite interesting as well that with the big iron ore miners, that sometimes if those autonomous devices like big drilling machines need to be switched off from the automatic controls, they actually use Xbox controllers to correct them in a manual mode. So that's pretty good news for the children of today, I reckon. But Realistically, also from the educational perspective, which was also highlighted by Simon, I think there's still some work to be done. So I think the universities also need some restructuring to assure that we not only educate traditional operators, metallurgists, and process engineers, but also assure that those components, like being able to conduct cloud computing and to understand algorithms and to work with all the digital tools moving forward, that they become standard practice.
Great. And not just universities, I guess there are many other kinds of education providers out there, including organisations like the ones represented by all of our panellists. So that's a really interesting point to finish on. We're just about out of time, so I'm sure we could continue this conversation for another 45 minutes. I guess it's left me with probably more questions than answers in my mind, because there have been some really interesting issues raised. And it's a pretty exciting journey. I think the message I'm hearing from everybody is that things are getting better, and there's some all kinds of promise on the horizon. So thank you to all three of our panellists. It's been great. And this is just a taste of the conversation that will be available for you at this year's IMARC, which is going to be on in Melbourne, 29th to the 31st of October. IMARC brings together more than 7,000 leaders and key players in the global mining industry, and it's going to be running a specific conference on plant and processing on Tuesday, the 29th of October. So some of these issues and various others as well are going to be gone into in more detail. Ben, I believe you're going to be taking part in that conference. Do you want to give us a brief overview of the sort of discussions you'll be having at IMARC this year?
Yeah, we're going to actually talk about real stuff. So we'll actually talk about real results and real impact on a variety of different mine sites across a range of different commodities with several different companies. So I think it's going to be a good time and a fun time to sit down and see what can be achieved if, as I said before, disparate groups can work together and they can create something that's a lot greater than the sum of the parts. So I'm really looking forward to it.
That sounds great. So there is going to be a discount offered to all webinar attendees, 15% off your registration. So have a look at the slide up on your screens. You can register online using the code that's up there, PLANTWEB. I don't know if it's case sensitive or not, but it's up there all in capitals. So go ahead and register and use that to get a discount. In the meantime, if you want to revisit this discussion, there'll be a recording published on Mining Beacon, which is the official content site of IMARC, and all registrants will receive that link via email, so keep an eye on your inbox for that. IMARC will be holding more webinars between now and October to give you a taste of some of the themes that are going to be covered during the event, or have a look at Mining Beacon if you want to find out what else is available. Our next webinar will look at mining in Latin America and the trade and investment opportunities available for Australian investors in that region. So finally, at the end of this webinar, a short feedback survey is going to appear on your screen. Let us know what you thought of the conversation, and also we'd like to hear how many other topics you can suggest that you'd like to hear about in the future. It will only take you a minute or so to do that, so we'd appreciate it. Thank you one and all, and thank you very much to all of our panellists for this very interesting conversation. I look forward to seeing you at IMARC in Melbourne in October. Thank you. Bye.
Thanks.
Thanks. Bye-bye.